Welcome everyone to today's presentation, PDFR, future revisions and highly efficiency compressed images for PDF, the state of the working group's research for adding new highly efficient image codecs to future PDF versions for up to 5 times, depending on the use case, smaller PDF and faster cloud scanning. So why a new image compression? The most used image compression in PDF today is most likely JPEG. It's, of course, a universally used standard from digital cameras to web browsers, web pages, but it's quite dated, 1992, and is using a technology called discrete cosine transform, DCT. It's usually achieving a approximately 10:1 compression for photographs, mostly. Of course, you can compress more, but maybe all of or most of you who have already looked into that, if you compress JPEG more, one usually gets relatively blocky images relatively fast. So you cannot just like 20:1 compress images without losing significant image details. It's based on an 8x8 macro block compression using this discrete cosine transform. And this is mostly bad for non-photographs, think PowerPoint presentations, other graphics, web images, synthetic images, especially with sharp edges. And with higher compression, this 8x8 blocks become also quite visible. There is a newer compression, JPEG 2000, also supported in PDF since that time approximately. And yeah, as the name implies, JPEG 2000 is from the year 2000 also, so only 8 years newer. And it is using a discrete wavelet transform that is rather special at the time, state of the art, of course. And it vastly improved over JPEG, natively supporting multi-resolutions, meaning multiple, like starting with a small resolution of a thumbnail. So if a smartphone starts loading the image, it can display this thumbnail, and the more data of the image is progressively transmitted, the more sharper the image becomes. It is, however, relatively slow. By nature, not that much has been done the last 20 years to speed it up too much. And yeah, year 2000 also already 20 years, a little bit dated too. So only very brief, how does JPEG work? JPEG is very simple in today's standards. It's doing color transforms. It's not working with what's usually often used in desktop anyway, RGB, red, green, blue images. So that is transformed to YCBCR. Then this 8x8 blocks, this discrete cosine transform is run on those 8x8 blocks. That result is quantized. So this means the numbers are the reduced, so to speak, like this is basically the major trans compression step, and reordered in a zigzag pattern in this 8x8 blocks to better to improve compression with this Huffman, with the last Huffman entropy coding step. The Huffman compression is also even older, I think maybe from 1972 or something, first proposed. So also very, very old compression technology. And this is basically it. So basically you could like draw 4 boxes of steps in this compression scheme. A lot has happened since then, since 1992-ish. And of course, all the research has been done in existing video codecs. Of course, of which there are many, with obviously DVDs, Blu-rays, and all the last years internet video streaming, YouTube and others, Netflix. So of course, everyone wanted smaller videos, higher resolution videos. So for 20 years, there has been a lot of state-of-the-art and huge advancements in image and video compression. And one of the more popular ones, H.265, is the latest, or the nearly latest ISO standard compression, is achieving not like JPEG 10:1, but 1000:1. This 1000:1 compression is, of course, not directly applicable to still images because videos only compress every 15th or so. keyframe, and the other frames are in less detail delta encoded. But so we cannot expect a compression of 1000 to 1, but we of course can do much better than 10 to 1 that JPEG does. H.265, however, is unfortunately heavily patented. That is not the most convenient thing for most software vendors to deal with. There are, of course, many other options that we looked into. So we looked into many major alternative codecs. One is Google's WebP. However, all of those codecs have pros and cons. So WebP, for example, only supports 8-bit, I think, or maybe 10-bit, but not much more. It also always does perform subsampling for 2.0 subsampling of further reducing image details, and other codecs have options to, for example, have 4.2.2 different subsampling options. So WebP not very flexible in the compression subsampling choices. The others, AVIF is another latest. It's using AV1, another open video codec from I think Open Media Alliance. It's already better, for example, up to 12-bit per color component. However, that is also relatively slow. You see there's always some pros and cons. And another is JPEG XL, the latest update. So ironically, the latest update of JPEG 2000, and now just this year's final ISO standard JPEG XL, up to 16-bit per color component, and also supports very flexible progressive encoding scheme for streaming, starting with streaming low detail and then gaining more detail as more data is loaded from storage network. There are also some other variants, for example, high throughput JPEG 2000, but this is mostly JPEG 2000 trying to make it less slow, but it's also compressing less. So we didn't find that in the working group that favorable. Of all the video codecs, so if we take a look, previously JPEG, a very simple codec, the new high efficient, so this class of video codecs is usually referred to as high efficient video or image codecs. This is this current class of much more coding efficient. And as you see from this diagram, this is, for example, this is probably H.265. It's just an example that this is much more complex, not simply running a discrete cosine transform. Of course, intra-picture delta encoding and scaling and motion estimation. So as you see in this block diagram already, this codecs have, of course, a much higher complexity of trying to find much more repetitive image details and encoding, achieving much higher compression. In the working group, over time, we focused on JPEG XL. Initially, actually, we thought H.265 or AVIF are the most favorable, but JPEG XL turned out, after looking into that more and more, JPEG XL is very versatile. It started as an ISO or working group project years ago as the next generation image compression. It's based on Google PIC and Cloudinary free universal image format. So there have been previous attempts of open collaboration of creating such a next generation image compression, and it combines ideas as old as JPEG, lossless WebP, and FLIF, which is this free or the successor of free universal image format. It's by design similar to JPEG 2000, very responsive and progressive in that it's not encoding one image, but a progressive layered design, so that, for example, one high resolution image is or can be layered as a stack of 8, for example, images, so that on a web browser or a PDF viewer, an image can already be shown with less detail, and the more data is loaded and decoded, the more detail is presented to the user. It typically achieves 20 to 50 to 1 compression ratio, so that is twice to 2.5 times better than JPEG. But we will see, in my opinion, you could even achieve better compression, because as I will present later, the compression artifacts of this modern next generation highly efficient image codecs are much more pleasant to the human eye than JPEG. JPEG always becomes very blocky, and if you compress scans or like business documents 50, 70 times, you can still read and view them and then much better compared to JPEG due to the nature of the compression artifacts. JPEG XL has a very interesting property, which is that it is backward compatible with JPEG without requantization. So you can, JPEG XL allows to take directly the previous JPEG image data, like internal compression data, and just re-encode this with new JPEG XL. For example, I think it's LZ77 or something, entropy encoding, and achieve without any loss of details or any new introduction of quantization noise, 20% smaller files. And it also supports directly reusing PNG or PNG 24-bit, 8-bit, or GIF, even including animations without additional loss, and always, according to the JPEG XL working group, always producing smaller files. That is certainly a very nice property of JPEG XL that the other video codecs from Hollywood-related video encoding do not share. JPEG XL supports up to 4,100 channels. That certainly should be enough for everyone. Usually you have like 3 RGB plus alpha, and then JPEG XL still allows for 4,096 extra channels like spot colors, depths, and so on. Not sure whoever would want to use 4,000 channels, but JPEG XL allows for it. It also allows a very high maximum resolution of 2 to the power of 30 minus 1, that is 1 billion something pixels. That is interesting because many other alternatives like AVIF and Hike at times only allow 8,000 pixels, for example. And that is, of course, a limit that you could often hit relatively quickly in your scan documents, think large format scans or CAD, computer aided design, geographic maps, and so on. And you could use other codecs in PDF and tile those, like having 8,000 pixel tiles, but often a small gap is visible between the tiles. So an image codec that natively supports such a high resolution is certainly preferable. Layered tiles, as I mentioned, for high DPI, for example, responsive web or high resolution PDFs, responsive PDFs, as I mentioned already, so of course nice. It has a lossless mode and natively progressive. And a very interesting feature is that it's variable, perceptual, metric adjusted quality region. That means in JPEG or other image compressions, the whole image is compressed with one set of parameters. And JPEG XL allows to have regions of interest, for example, regions with more contrast, with more detail, to use a higher bit rate of compression and details, and in areas without much detail, like an office scan background or other, like the sky of a photograph or something, where there is not much, if it's like a blue sky, and details like this, to use less compression bandwidth for those regions where there is not much detail anyway. And all this details in this codec allows for this very high compression, where other JPEG old legacy image formats like JPEG would waste a lot of data of compressing a blue sky, for example. It supports high bit depths nowadays with this wide gamut and HDR, certainly interesting. And it also works very well for any kind of content, not only photographs. The old legacy old JPEG only works very, very good for photographs. JPEG XL also works very well for illustrations, renders, which historically worked better with PNG, for example. And in a moment we will see why. As I said, it has a what they call variable DCT block sizes. So instead of 8 by 8 blocks that JPEG uses and with high compression often looks very blocky, has variable block sizes between 4x4 to 256 by 256. It is of course very nice that you don't have this JPEG 8x8 blocks to result in very blocky images. It has an optional, so these are the two main encoding modes. Variable DCT is one. The other is modular mode, especially for synthetic content sync. Such kind of presentations like this, other office graphics, where historically JPEG didn't work well. So JPEG XL has a mechanism built in to optimize specifically for the input pixel data. It has features like image features are rendered on top of the decoded image. So image features are, for example, high contrast elements, lines, or even noise. So instead of wasting encoding bandwidth of compressing noise that, for example, you scan an office document and you have a noisy background of your paper, JPEG XL allows to optimize this of generating this noise and applying such kind of noise or other image features on top of the decoded image, which is one of the many of such detailed features of JPEG XL that helps with such high compression ratio. It's using, similar to other codecs, prediction of like predicting what, based on the previous pixels, what the next pixels will be. A feature also historically, legacy JPEG does not have restoration filters, and as I mentioned, adaptive quantization of depending on the details in this area of the image. It also includes the modified nonlinear HAR wavelet similar to JPEG 2000, enabling even more efficient and progressive decoding. And as already mentioned before, high bit depths, wide gamut of higher color accuracy, and also maybe not as relevant for PDF, built-in animation support that JPEG 2000 also didn't have. I'm not sure if that would be directly supported in PDF, but at least it is there. So JPEG XL internally, it looks a little bit like the video codecs, but in detail different, of course. And that is a benefit of JPEG XL because it doesn't have this kind of motion picture interframe data frame complexity in the codec. It can purely focus on still images, where other alternative motion picture codecs are not as efficient as used elsewhere. And instead, it has the second modular mode that is optimized for synthetic images. So it basically decides, the algorithm, the compression algorithm decides, is it lossless? Then decide on the encoding, and also what kind of image content is it? Natural or synthetic. And if it's natural, then it's using this variable DCT and other image feature and so on encoding, or alternatively, it's using this generic mode. And this generic mode has stuff like features of recognizing gradients, like in this presentation, this gradient, it can more efficiently encode similar to PNG or GIF and so on, directly encode such synthetic images instead of using much more bandwidth that this classic DCT decoding would use. The way it works to reuse JPEG data, by the way, is simply to feed in here. This is your JPEG bitstream, directly feeds the coefficients from the JPEG bitstream here into the JPEG XL bitstream encoding. That is actually a very nice feature. JPEG XL is also very fast, much faster than the motion picture high efficient codecs like H.265 or even AV1. About as fast to encode and decode as JPEG, at least the open source reference implementation. This, I think, from the Mozilla Foundation libJPEG Turbo, which is a more thread and single instruction multiple data optimized version of libJPEG. So it is much faster than I expected. Especially these video codecs are often a magnitude slower. So that is an interesting benefit. Initially, I personally preferred some of those video codecs because just so much research went into that. But the more I looked and tested with JPEG XL, I actually came out much more impressed. So order of magnitude faster to encode and decode than this other H.265 based, and also by design threadable, and also already supporting vector extensions of modern CPUs is single instruction multiple data. Here I have an example. I hope it comes over. So that is of our testing. So at Exactcode, we actually implemented proof of concept code for all of those codecs as part of this working group testing. And this is just some of our test documents here in the office. And I hope the compression artifacts are as visible. The compression is amazing, right? So this is a, I think, 200 dpi scan it was, compressed with JPEG. And this is a very, very high compression ratio, right, of JPEG. Of course, normally if you give JPEG enough bandwidth, JPEG of course also looks good. But if you want a very small files, like say compression slider of your software, like a 20%, then of course everyone probably has seen that the file become extremely blocky. And this is a quantization of removing, of quantizing the coefficient there, and thus quantizing the image data to this levels of color, which then results in this blockiness. And the JPEG XL, although it is like, I think, like a fifth, like 30 kilobyte, it looks much better, right? The color is much better. The overall reproduction is much better. And that is with, these are extreme cases. Of course, you can achieve much better visual quality if you give more bandwidth to both of the codecs. But we find it most interesting to look at the limits of codecs, right? It makes no sense to look at codecs of when you give them enough of data, everything looks amazing, but everyone, of course, wants small files. So we usually find it most useful to study codecs when you select very, very high compression to actually see how, like, the worst case still usable threshold would be. So I personally find this pretty amazing, 5 times smaller, yet much more detailed and readable. And as you see, the JPEG has this very pronounced 8x8 blockiness, and due to the variable nature and much more like residual encoding, refinement, image details, and so on, much better visual quality of this JPEG XL codec. I have a second example. So this is not one, we studied hundreds of images when we worked at that. And this is, of course, JPEG 67, not the small thumbnail 67K, right? The whole Office document, I think over 200 dpi scan. The whole Office document is, that is an envelope. Of course, the whole Office scan 67 kilobyte, and the whole document. This is only a zoom in to study the details. And again, and this here you also see again the blockiness and loss of image detail of JPEG compared to JPEG XL, which can much better model gradients and details. I created a feature overview that's probably best for you to look into the PDF handout if you like to. Basically, the feature basic overview of what is supported, for example, HDR, progressive, this is the maximal file sizes that I mentioned before, not file, also image per file image sizes. JPEG had 64K, and WebP only 16K, 8K. And here also 8K, so this is basically image video codecs of typical 8K derived. And this can be a problem. Of course, it's usable to tile an image, but it's of course preferable if you don't have to tile JPEG XL to the power of 30. So that is 1 billion something. That is certainly, again, enough for most people. How to add this to PDF? That is currently in discussion. We prototyped this with a new X-object filter type. Historically, there are things like DCT decode, JPEG decode. Unfortunately, of course, nowadays one would choose JPEG decode, but that already exists for JPEG 2000, unfortunately. historic. It would have been nicer if that would have been named JP 2000 or something, or JP2K, but it isn't, so we cannot use JPX, although, so maybe JPEG XL. We are currently still looking into whether to support maybe both JPEG XL and AVIF. They all can be stored, all modern codecs you often use and can be stored in an ISO base media file format, BMFF. So maybe that could be a BMFF decode filter supporting all of those, and with a subtype or whatever details. So the details are still being discussed. That would, of course, be the logical steps. There are, of course, some questions, for example, how to handle extra channels, like the, what was it, 4,000 ones, 4,100. That is, of course, overkill. There, of course, needs to be some standard text of how many channels are allowed, what to do with them, like spot colors. Also, HDR content. Some people are actually interested in HDR, high definition range content. So there are also some new possibilities there with JPEG XL, for example. What are the benefits? Benefits are, on average, at least up to plus minus, depending on the use case, 5 times smaller PDF images. Faster transfers, of course, the smaller the file, the faster your email sends, your web download loads, so smaller archives. HDR more than 8 or 10 bit per sample. At times, GPU hardware accelerated, depending on which codecs we choose and support, and hopefully future GPUs support JPEG XL directly, and directly embeddable from some modern smartphones. We are currently in the working group looking at supporting JPEG XL and AVIF, and some Google-based and Android-based smartphones already support AVIF photographs, so those could be directly reused. From the Twain working group, where we started to standardize PDF raster, we are, of course, very interested in speeding up network transfers, network scanning. This is why in PDF raster we didn't support JPEG 2000 initially, because it was already so dated and we were preferring to look at more modern solutions. Any network, or of course especially Wi-Fi and cloud scanning, could easily be 5 times faster with this new codecs, and directly reusing this. If today Inventor supports this already, PDF proper would need to support this to directly use this data without re-encoding this if a scanner already supports sending such highly compressed data, or, as I said, archiving photographs from your smartphone. Yeah, it's an ongoing working group project. The major discussion took place this year. JPEG XL and AVIF are the primary candidates so far. We looked at many, as 8 or so. The major ones I outlined in this presentation. The detailed codecs, channels, HDR still need to be discussed. If you're an expert in this or have requirements, feedback and requirements appreciated, just let us know. It's a PDF Association or you people in the ISO standardization process, and with future revisions of PDFR, the raster variant of PDF that we standardized last year, we would likely only support only one codec. So if the working group project comes out with supporting 2 codecs, we might choose, for limiting the complexity in PDFR, 1.1 revision envisions the next years to only support one currently preferable JPEG XL. But again, this is our ongoing project. This is just some brainstorming of what we are currently working on. Yeah, that is the presentation of high efficiency codecs for PDF and PDF raster. I hope you learned something from this, maybe new codecs or details. And if there are any questions, I'm happy to answer them.
That's great, Rene. Thank you so much. Rene's slides are available for download from the handouts pod in the GoToWebinar control panel. So I see one question here. Does JPEG XL support color management, which would be, of course, of great interest to the printing industry?
Yes, JPEG XL, of course, supports ICC profiles. And that is, of course, the details that need to be standardized. That is one open question. But we have this already today with JPEG and JPEG 2000, that those bit streams can include ICC profiles. And these are exactly those details that need to be standardized. What to do if the PDF specifies an ICC profile, for example, and the file as well, or which to prefer, or this kind of details needs to be worked out. But yes, of course, and of course you can use a or today we envision to use the standard PDF mechanism where you anyway, as far as I remember, can specify an ICC profile. So yes, of course you can use and combine this.
Okay, excellent. Next question, what about bitonal images?
Yes, I think JPEG XL supports it natively. So JPEG did not, did I? I didn't even include it here. But I think JPEG XL, as far as I remember, actually supports 1-bit. I think it also supports less than 8-bit. So I think 2 or 4-bit probably should also work. But in any case, it is it has this, as mentioned, this modular, is it called modular? Yeah, modular mode. I think it supports 1-bit bitonal images.
Okay. So a question on this, on the standardization aspect. When do you think that this technology might be releasable as an extension to PDF 2.0?
Who asked these questions?
Yeah.
You are one.
No,
So
no,
I
that wasn't
personally,
me.
okay. I don't have that much experience with it. I would hope that maybe 5 years, but it of course depends. Maybe other PDF veterans are better asked that question. I personally would hope for maybe 5 years, but maybe that's optimistic. But yeah, it depends, of course, as always, on the ISO standardization process and
Right.
what fits in other PDF standardization and what kind of time frames and slots we get into there and so on. And what is the interest, if there is enough industry interest, if maybe it's not even standardized at all if nobody votes for it. So it's of course not us alone that decides the time frame. But I hope sooner than later.
Yeah. Okay, next question. Are all of these compression options open source projects or commercial software?
Yes, so that is a big benefit of JPEG XL. All of this is open source. There is from the JPEG XL working group an open source reference implementation that I personally worked with on GitHub. I tested with that, and as far as I've seen, all of this is supported in the open source reference implementation. And that is a big difference to, actually I should have had this in this table, especially with Hike, this high efficiency image codec that is using H.265 from motion pictures. That is what Apple is using in their smartphone. So Apple's iOS can create from the camera directly Hike images. They use H.265, and the problem with that is it's highly patented, right? There are open source implementations, but if you ship and use this commercially, you need a license. So that is a big benefit that I see for JPEG XL, that it is set to be not covered by any patents and royalties. I hope it stays like that. You never know what happens with people finding patents in the basement, but that is one of the big benefits of JPEG XL as well.
Mm-hmm. Are there any applications at this time that can handle or create JPEG XL?
So JPEG XL is widely supported. Even some web browsers support that natively. I think Safari and Chrome probably, and also other software. So even open source software and other software. And for PDF, here at Exactcode, we have a prototype handling actually all of those major codecs. And my understanding is Adobe also worked on prototyping that in their PDF software as part of the working group. I think at least JPEG XL, maybe others. So there should be at least two PDF prototype implementations around at the time. And yeah, others are of course welcome to join this effort in the working group to work on this.